looky what we have on the bench today. This is just amazing looking. These are some vintage bells that you would hang on your door. And the customer sent this in. It's been in their family since they were a child. We're talking probably 1950s. He said he remembered these being on their door every year. And see, for doorway or for fireplace. And they were made by E.J. Nakorovo Manufacturing Corp. South Amboy, New Jersey. For REITs or for Windows. And of course that's not Microsoft Windows. It's real Windows. The bells of St. Nicholas. Hear them ring. See them sway. Plug them in to hear them play. Directions. Suspend activating unit in desired position and place. Activating units may be turned so bells will sway in different directions. Hang free from obstructions so bells have full sway. After inserting the plug, allow approximately 60 seconds for warm-up time. Our product is guaranteed for quality workmanship. I don't doubt that. I imagine they would still be working somewhat. Suggested use, decorations for doorways, windows, fireplace, parties, showers, weddings, etc. Save this specially designed box to preserve and safeguard your set for year to year. Seems like it's done that job. And approved by Underwriter Laboratory and the registration U.S. Patent Office has been applied for Action Windows display. So, customer sent them in. They swing, they sway, plug them in and hear them play. Automatic Christmas bells. Sent them in, said that, of course, you know, they're not working. So the question is, why not? We want to be very gentle with the box. You can see it's two-section display box. And here's the set. And we got a tag here. That's an important notice. So check that out. That's a plug in a plug. So what's the deal with that? It's got a catalog number, 100 watts, 110 volts. So it's 50s. Bakelite plugs. And this one just plugs into that one. I'm not sure what that's all about. That's interesting in and of itself, right? A plug that you plug a plug in and then plug it in. I don't get it. I don't see any difference in the plugs either. Strange. Okay, well, that's the way they gave it to you, so that's the way it is. And the bells are most likely little solenoids. That's what I'm thinking. So we're going to take them out gently and set them down and see if we can figure out what to do with them. Very gently. They are very in there. It looks like they've been in this cardboard for quite a while. I want to be very gentle with the box. I know it's old and cardboard, you know. It's already suffered some issues with age. Okay, and that one needs to come out. All right, let me get the box out. And you see, yeah, it's already suffered some issue, right? And this was perforated here, so that's this. Well, I don't know. It's perforated for a reason. There must have been something that was down there. Excuse me. So what I'm going to do, if the cord is long enough, is plug this into my current limiting variac so we can find out what's going on, which ones work, which ones don't work. and what we're supposed to do, what we got to do to get them all to work. Okay, so we'll plug that in over here. I'm going to have to get in front of the camera. The bells are fine. I noticed this one has a little dent. You can see where it was hit there. It was in the box, like that. This one, this plug came out of here, which is probably just an electromagnet, so it's like a relay. The others seem to be in. That's what these chains are for. They don't keep it so that don't come out. So why did that one fall out? Hmm. I don't know why that one come all the way out. It's got a little bit too much slack on it. We'll have to adjust that. I see. Probably need to raise that one notch. Yeah, one ball. See in here? You see there's an extra ball here. This crimp thing needs to be up there, up underneath that. And there used to be a spacer. See the spacer in there? There's no spacer in this one. That's why that bead is showing. The spacer was there and covered that at one time. See, these have spacers and they're deteriorating. You know, they are old. This one's missing its spacer too. So that's why the plunges are falling out. And it's got a little bit of wear, but they're actually in pretty good shape. You know, some of the paint is nicked, but that gives them character. All right, give me a second to turn this up. We'll bring it up to about 50 volts, 55 volts there and see if they do anything. We're drawing 10 milliamps of current, so something is working. Okay, I don't think it's enough current to pull them in. Well, that one's trying to go in. How about you guys? He doesn't seem to be pulling. That one seems to be pulling. So this one, okay, let me bring the voltage up a little more. Sorry to keep getting in the way. Okay, that's 20 milliamps, and I'm at around 85 volts. Let's see if we can stand them up like this. None of them are ringing. Interesting. All right, I'm going to turn the voltage up fine since we're only at 20 milliamps. Okay, that's 112 volts. That should make them ring. Oop. Oh, okay. Okay, that one's working. Let's see if we can get this guy to work. That one is working. I think this one's working too. Yep, see? Okay. How about this coil? It's working. How about this coil? I think he's working too. I think these just need those spaces. All right. So, that is so cool. I'm going to go ahead and, okay, the question is why are they falling out? I don't think they're supposed to fall out like that. Which one is not? This one's not. Yeah, I think it's the spacer that's making that difference. It's ironic that something as small as that would make that much of a difference. Well, this one don't have a spacer. Yeah, I can see it's falling down. And these that are falling out, does that have that has a spacer. That one's working fine. Yeah, so the two that don't have spacers are the ones that are falling out. Okay, let me shut that off. And we will try to put some spacers in there. Let's see. I have some nylon standoffs. I don't know if they're too big. These are 1/4 inch. I'll have to try to cut them down. Yeah, I would have to try to cut these. Let's see how much. There's one that works good. This one seemed to work the best. I'm thinking I might be able to get 2, maybe 3. Yeah. They appear to be about 1/8 of an inch, but they're shrunking. Still got a little bit of magnetism there. Yeah, it's shrunk down, so these may be too big around for the chain. Oh, I guess not. I guess not. Let's try one of these. These are nylon. I gotta figure out how to cut them. Let's see something. These have a small hole, but these are threaded. Those are threaded. Aha! Well, looky there. And those are about, they may be a little bit smaller than that. I love buying hardware and things like this because you never know what you're going to use it for or when you're going to need it. I'm sure when I got these, I never thought, these would be good for swinging bells from the 1940s, 1950s. All right, let's start with the first one. All right, so to get that in there, first thing we need to do is disconnect it here. Maybe that. Yeah, I'm assuming that is hanging down the right amount, yeah, right into that groove, so maybe this side would be a better place to start. You know what? I'm thinking maybe not. Maybe we will open this up gently and try to get it off. I hate doing this, these are definitely old. Just makes more sense to do it from here. I'm going to get that bead out of there. Get a bigger screwdriver. Maybe this one. I really, really would like to get it off right here. I hate bending these down. They're so old. I want to break them. It's not enough to get the bead out. The good thing is they haven't been folded back and forth over time. However, they seem to be really tight in there. This side here that's not opening.
may not do them all that way. It's kind of a learning experience, right? But this gives me a little more slack to figure out how to do this part here. Yeah, good. Now, one of these down there. I'm going to take that off. One of those on there. And then put that back on. Before I put that back on, I'm going to clean it up a little bit. Yeah, we come up and clean it a little. Just get whatever little bit of built up of rust there is. That kind of still. It's the only place I see any on the sides are fine, but yeah, it looks better. Okay. Now, I'm going to go and turn around there. See if I take that ball off, it gives me more room to work with this. Okay, I'm going to put that back on. Let's try that. I'm not going to pinch it yet. I'm just going to put it on there, maybe. Okay, pull that up. Now that goes right there, right at that point. Again, I'm not going to pinch this close until I know it's going to work. Trying to keep it in the camera, and I'm kind of far away from it. That's fine. Open up the hand just a little bit more. Tight fit. Maybe on the next one I'll just try to do just a bell on the top, but I wanted to make sure that I could get it back together. I think I get it. Acting like it needs 2 beads. Okay, here we go. Alright. I'm going to close that up now. Right there. Something angle of pliers here and do a better job than my fingers. I'll get this mark. Match them. Okay, it goes all the way. How about that? I don't think they would have hired me at the company. Okay, that looks good. Now let's get that back in there. I think that'll keep it from falling out. I need 2. There's a trick to it, I'm sure. There's got to be an easier way. Okay, well that seems to be staying in. And if it did fall out, you can just simply put it back in, but it doesn't look like it's going to fall out on its own. Okay, so the way it was more like this one. See how they fall out on their own? I think that's going to be okay. Yeah, I think this is going to be all right. And that's about the same thickness as what's in there. Maybe it might be a little bit less, but I don't want to put 2 because I think it'd be too tight. But it seems to be okay. Let's turn it on again. You're right about it taking about 30 seconds to warm up. A little bit confused as to what the warm-up deal is. And is this one affecting the warm-up process or not being in there? Yeah, okay, maybe they have all be working in order for them to work. I'd say that's a repair. I don't think the thickness of the spacer is as critical as the fact that it's got to be there, because you see how it keeps it at an angle, so that the ball can't just swing around and fall out. So what do we got on top? We got 1, 2, 3, 4, 5 balls between here and here, which that's what keeps it from falling completely out. And we got 1, 2, 3. We got, actually that's not the ball, that's the pin there. So this one has 3. This one has 3. Okay, yeah, they're the same. But you see what I mean by the angle? So cool. All right, let's see what these guys are doing. See, notice the difference in the angle? This orange one is facing more down toward the straight, more down. It's a bigger angle between here and this bell than from here and this bell. And that's because of the missing thing. What I'm curious about is why this one isn't falling out. I think it will in time. See, it's almost a 45-degree angle, and now it's stopped. So it dropped down too far, and it actually stopped. Now, I don't have them, well, I got it at 10 volts. It does build up a charge. I'm looking at my voltage meter, and the voltage drops when the bells swing. So there's a little bit of a voltage drop. Okay, hold on. I give it full power. It's 110 volts, but it's now got full power. Okay, now the voltage is now fluctuating across my current limiting bulb a little bit. I would think that that's just, I see it fell out when well, probably my fault, I might have hit it. No, they're not. Hold on. There's something going on. They do get a little warm. What's up with this guy? It pulled all the way up in there and got locked. Oh, there it goes. It's stuck in there. Now that's an opposite effect. Probably because I set it down the way I did. So even the ones with the spaces will fall out when you move them around. But once you got them, I don't have enough hands. Let's try this. I don't know if that'll hold them, it's not very strong. Right, I'm going to put something heavy on that. Next is, let me pull that a little tighter. This would be this one, I guess. I don't know which one. No, that way. Okay, go that way. They do wrap around each other, don't they? And this one here. I'll adjust them when I get all of them on there. There's a lot of weight on it. But this one needs to be repaired. Right, now let's see how we can fix this. Easy with this. Take it off, just leave it there. Put this back in there. Now the wire's fighting me. Hold on, I gotta go this way. Go over there, go over there, go over there to the room. Get these back together. This one needs to be repaired. So that's what happens when they don't have the spacer. This one, I just haven't put it back in yet. Oh boy. Rocking and rolling now. Okay, I'm going to try to just take just the end off on this one and put the spacer on. Give me a second. I'm going to shut them off. And we'll try to do it while I got it here. I don't quite understand the time delay.
And it says there is a time delay. It says approximately 60 seconds. And sure enough, I don't understand what makes the time delay. It's like it takes that long to energize those coils. Just cleaning that a little. Okay, I think I'm pretty well done. I may play around with them a little bit more, but I don't want this video to be too long. I appreciate you watching the video, and hopefully you enjoyed watching these bells going berserk. Hopefully you'll be able to see this. What I'm thinking is, now this is just one unit, one cylinder. So we got a cylinder, and we got a pole that goes up into it, right? Well, in this cylinder is a coil. And the two wires, two ends of the coil come out the top. That's these two wires. When the current's going through here, it creates a magnetic field, which pulls this metal rod up, just like a magnet attracts it, right? When the current shuts off, the weight of the metal in the bell just drops down. This chain on the side is just to keep it from falling on the floor, right? Falling completely out. They can't fall but beyond where that little chain will let them fall. But what I'm not sure about is, why is there not current going through this coil all the time? The only thing I could think of is that inside here is a capacitor that goes across that. And maybe a diode. It could have a diode. I don't know. But there could be a capacitor. Or it could be a resistor. It could be an RL circuit, resistor, and a coil, in which case it takes a while for the coil to build up the magnetic field. If it's an LC circuit, you would think it would oscillate faster than that. And it's like it just, they're interesting. I don't know what makes them not just stay on, like a relay, you know, it's always on as long as it's got power. Okay, like I said, this video is getting long. If I think of anything, I'll add it to the video. Thanks for watching. Okay, just an update. I figured it out, sort of. I haven't figured it all out, but this is warm. When it's running, this gets warm. The wires don't get warm, but this gets warm. So in here is the key. So what I did is I took it out, I unplugged this. Can't do while I'm holding it, unfortunately, but that comes apart. So I unplugged that, and I plugged just this plug into my Variac and slowly turn the voltage up. And what happens is they go in and they don't drop out. They just go in and stay in and vibrate. So the circuit is in this plug. That's why there's two plugs. And that's why it got a little warm, because there's probably a capacitor or something in here that builds up a charge and then discharges through the coil, through the wire, which makes the bells ring, and then builds up a charge again, and then when it gets to a threshold, it discharges through this plug, makes the bells ring again, and it's something to do with that. I would love to dissect this thing, but I'm not going to do it because it's not mine. But yeah, I'd love to know what's inside of there. It's got two screws that just take it apart, And there's something in there besides the plug, obviously, because it got warm, and warm to the touch. Not hot, just enough to let me know there's some electronics going on in there. And this one wasn't quite as warm, and the cord was cold. Cords don't get cold. The coils don't get, they're about maybe a couple degrees above room temperature, but not like this. So, and that's to be expected. They are coils, so when they're on, the current's going through them. They're going to warm up. It's cold in here. It's winter time. But this thing here is the key. Don't ever lose this piece. You lose this piece, they're not going to work. That's what makes them work. If they ever stop working, a note to the customer, send it back to me. I'd love to be able to fix this, because if I could fix it, I could also find out how it works. I'd like to know. Anyway, thanks for watching. Have a great day.